So today we'll look at piecewise functions, so that I can also use this concept to help us understand those questions. A piecewise function is a function of this nature. So I think we'll just go straight to examples, where you sketch one, f of x plus 1 for x less than 0, x minus 4 for x greater or equal to 0. So the function defined in this way, then they'll ask us to sketch this function. So sketch this function. The definition of a piecewise function is telling us that in the same f, there are actually two functions. The first one is f of x is x plus 1, provided that the values of x that you use are only those values of x that are less than 0. So even as you are sketching, you must keep that in mind, that I'm dealing with the f whose values of x are less than 0. To avoid skipping any real number, I will start with the same 0, substitute it in f, 0 plus 1, we get 1. Now we have a point 0, 1. And what we'll do is, because it's less than 0, 0 is not included in that domain. It's just being used as a boundary number. So we're going to open there. It won't be closed. Then I'll pick a number that is less than 0. Suppose we use -1. What is f of -1? It will be -1 plus 1, which is 0. So we have a point -1, 0. And so the sketch of this point, of this function, will be like this. You leave it like this. And then go back to the other function. We also have 2, or let me do it from here. We also have 2, f of x is equal to x minus 4, for as long as the values of x being used are those bigger or equal to 0. First number is 0. F of 0 is 0 minus 4, which is equal to -4. This means that you have a point 0, -4. This time around, you include that point. Pick a number bigger than 0, say 2. What is f of 2? F of 2 is 2 minus 4, which is -2. So it's giving us a point that is inside there. So we can sketch this function going this side. So the point must be inside there. Once the function crosses the the x-axis, the point of intersection must be known. And the point of intersection here will be getting the x minus 4, equating it to 0, then solve for x. You get 4. So that is 4. That's how you sketch this kind of function.
Sorry, sir. For f of 2 equals to x minus 4, where you got -2. I'm not seeing why you didn't show the -2 or what. I'm a bit confused there how you sketched your graph. I thought it was going to go the opposite direction.
What do you mean the opposite direction? -2 is bigger than -4. So it will be inside, between -4 and 0. Remember, these are negatives. Is it okay?
Sorry, sir. The part where you use the f of 2 equals to 2 minus 4. I'm a bit confused. How did you draw the line from that? I understand the first part where you use 0. Now the second part where you have f of 2. How is the line passing there?
Okay, how is the line passing? Look, what is f of 2? We have said that f of 2 in this function will be 2 minus 4, giving us negative 2, is it? So I have a point 2 comma negative 2. So 2 comma negative 2 will be a point here. Because we already have 0 here, we can connect the 2 points going that side.
All right, thank you. I've seen it.
Okay.
So I'm sorry to ask, but where did you get the question from? As in,
As
Sam.
in,
For me, I just entered and I found this question. It's a question it's the one we were solving.
no.
Hmm?
Today we're looking at the piecewise functions. And so just look at the examples of piecewise functions, and the first example we have is this one.
But what is the question?
The question is sketch, and f of x is given as this.
Oh, it has already been defined.
Yeah, it has already it's being given as a piecewise already, not the modulus. It has just come
okay,
like this.
Okay.
Oh,
All
okay,
right, thank you then.
Okay.
So we just kindly explain from the start.
Let me have a question.
Please ask.
So, the first one, why isn't it passing through 0? Since isn't it negative 1 comma 0? Or is it 1 comma 0?
It's negative 1 comma 0.
The 0 is for the x.
The 0 is for the y. Yes. Your points will always be x comma y. So negative 1 comma 0.
So it's not like it's passing through that one in the y.
There it's going there. At that point it will be, that is 0 comma 1. So it can't pass through there because it's blocked. Its domain ends at 0.
Oh, okay.
So I want to ask, where is the negative there? The two ways it coming from.
Okay, someone is saying just start a phase. You guys, these functions are nice. And they're easy because they're just straight lines. Okay? So if you are given a function of this nature, f of x is x plus 1.
Repeat from the start.
Okay. So f of x is x plus 1 for x less than 0. The same function is x minus 4 for x greater or equal to 0. The first thing to do is you pick them as pieces. Okay? So how do you pick them as pieces? You have f of x, the first piece. The first piece, f of x is x plus 1. For which values of x? For the values of x that are less than 0. So I'll start at 0. Pick 0, take in f. So you have f of 0, giving us what? 0 plus 1, which is 1. Now that we have 1, we have a full point 0, comma 1. But should we include 1? No, because 0 is not included. It's just being used as the end point, as the end number. Okay? So you don't go beyond 0. You can go closer to 0, but not beyond 0. Not even at 0 itself. Then now you pick any number that is less than 0. So we have picked negative 1. After picking negative 1, lucky enough, it gave us the intercept for x. because it gave us 0. So we have negative 1, 0. Then we draw the line going down, because even if you picked negative 2, it would give us something less than 0, a negative value. That's why the line has come like this. Now we have two pieces of this function. The first piece has been sketched. Now we got the second piece. The second piece starts at 0. This time around, this guy includes even 0. So you pick 0, substitute in the function, and get 0 minus 4, giving us negative 4. This is forming 0, negative 4, where negative 4 is now included. So you include it. So you include it, and as you include it, you go to your right. How do I know I got the right? I pick a number bigger than 0. Since I'm only allowed to use values of x that are 0 or greater than 0, so I've picked 2. You substitute 2, you get 2 minus 4, which is negative 2. So we put a point 2, negative 2, 2, negative 2. We have a point there. And then we can now draw a line going this side. But because our line crosses the x-axis, we need to know that intercept there. So we get x minus 4 equated to 0, and so for x. So x is equal to 4. Have it here, and that is the whole line. So how we learn this? We get one or two concepts here. Another example, so you can see the connection.
So, sir, upon you getting the two, that question,
Uh-huh.
I'm saying since you got the 2 and you placed it in the function there, so apart from, you can get any number, for instance 3, since it is also greater than x.
Yes.
Can you even replace it?
Yeah, I can use even 7, a number, and replace in there. Okay. Another example. Another example. Example 2. F of x is
Hello, sir.
equal to, hello.
Are we done for the first question?
Yes, we are done.
We're done. That's all.
Yeah, that's all. Just sketch.
Oh, okay.
Yeah, so all in the dot, well, just those lines.
Oh, it's simple.
Very. Okay, another one. Negative x minus 3 for x less than negative 3. And 9 minus x squared for negative 3 less or equal to x less than 3. And x minus 3 for x greater or equal to 3. Here is another piecewise function. How many numbers do we have? 2 again. We have negative 3 and 3, giving us the boundaries of all the 3 functions. So if I had a line like this, I have negative 3, I also have 3. So from here, going to the left, this f of x is negative x minus 3. And from here all the way up to 3, this f of x here is 9 minus x squared. The same f, starting from here, going this side, it is x minus 3. The same function, the f, it is changing its nature depending on the interval you find x from. That is the meaning of the piecewise function. So, and you want to sketch this, so let us sketch it. So we have -3, we have +3. So before -3, we have -x minus 3. So we'll get -3 itself as our boundary number. What is f of, so we might need that space. So what is f of -3? -3, it will be -3 minus 3. The function we're using here is -x minus 3. So that we get 3 minus 3, which is 0. So we have a point at 0 and we don't include it. We open there because -3 is not included. Then now you pick a number like -4. So what is f of -4? F of -4 is equal to -4 minus 3. That is 4 minus 3, which is equal to 1. So we have 1 and a point there, meaning that our sketch comes from this side, this direction, all the way up this one. They are lines. So not complicated. Then we come to the middle one. It is 9 minus x squared. This guy is not a line. It's a quadratic. A quadratic gives us a curve. So we are dealing with a curve. So we'll start from where now? We pick the same -3 again. So what is f of -3? This time around, our f, because we are in this interval, so our f is 9 minus x squared. So we'll have 9 minus -3 squared. This is 9 my, hello?
I have a question. If we had picked -2, we'd still have shown us the line.
If you pick -2, it means that you are in this interval now. Between -2 is bigger than -3.
Oh, we have to, okay, all right.
Yes. So -3 squared is +9. So we have 9 minus 9, giving us 0. At this point, we go to this one and close it. We have closed it using the middle function. Then we'll go to its end. It's ending, remember, starting from -3, ending at 3. So we got its end and get 3. So what is f of 3? F of 3 will be 9 minus 3 squared, which is 9 minus 9, which is equal to 0. So we have another point, except that this time around is not included there. So we'll open. Okay, I have hands up. Chirufia. Oh, I get from Blessings.
Sir.
Hello.
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 Sir, can you hear me?
Yes.
I was wondering about the line of -x minus 3. It's not supposed to go down.
It doesn't go down. It ends just at -3 there.
But sir, when you put any value of x, it's given a negative. Whether positive or negative, it's given a negative.
Like which value?
Like when you put 0.
0 is bigger. 0 is bigger than -3. So we can't use 0 there. You only use the values of x that are less than -3.
Oh.
You get?
Yes, I do.
Okay. So now We've used the 3.
Excuse me, sir.
Okay.
The reason why the graph, I'm kindly asking, why is the graph coming upward, like to -3? Is it because that when you plug in the values of x, it is giving us a positive of y?
Yes, it's giving us positive values.
So if we had something like it is giving us y, it is negative, it would have been coming downward.
Yeah, it would have been going downward, yes. So there's a question that how do you know that now is included or not included? If you have less or equal to, you include. If I only have less, exclude. If I have greater or equal to, I include. If I only have greater, I exclude. That's how we know. Do we include or exclude? That's how we're going to know. Okay, so now 3 is not included, so we have put a circle there, make a hole. Then now we want to sketch, but this is not a straight line. So having 2 points only won't help us. We need another point. Now the good part is that the y-axis is in between these intervals, and we find 0 here. So if we use 0, it will help us know the y-intercept. Because remember we said every time we're sketching this, we must know the intercepts. So now what is f of 0? 0 is in between this same interval. So we substitute in the same function. So we get 9. So go all the way up to 9 and then draw the graph. At least now we know it's a quadratic and it is going like that. So it's going to go this way. From there, what else do we do? We are done with that. We are done with this. We now go to this third piece where f of x is equal to x minus 3. So get the very 3 because this one is starting from 3. So get 3, substitute in the function. So we'll have f of 3 is equal to 3 minus 3, which is equal to 0. So we have 3, 0. So we'll come back here and close because this function has closed. So close. After we close, we pick a number bigger than 3, say 4. What is f of 4? That will be 4 minus 3, which is 1. So we have 4, 1, meaning that this guy is going to go like that as a function. So that is our sketch.
Sir,
Hello.
yes. Now you are using different color or different ink to show, but how would we show that the quadratic there, it's an open circle, yet at the same point there's one which is closed? Are we supposed to make one graph, or we can make as many as possible?
Now the fact that the other function is closing, it's not necessary to show that it was open at some point.
Okay.
Yeah, it's only necessary to show that it remains open if no function is coming to close. Otherwise, you don't need to indicate that it was open at some point. It can just show as if it's been closed.
All right.
Yes.
Sir,
Hello.
is it a mandate that you have to draw all 3 graphs on one diagram, or you can draw different ones?
It's a mandate because this is one function, f of x.
Okay.
Sir,
Sir,
Hello.
sir.
I didn't understand on the last equation where you said f of 4, the one that we had picked, which is greater than 3, how the graph went,
So because
how the graph had gone before.
when you used 4, we got 1. So it's like we had now a point above the x-axis there. And since x is not squared, so it means that you're doing the straight line. So having 2 points is enough. We have the starting point, another point there. So just draw a line connecting those 2 points. And then the line keeps going.
Okay.
Yes.
It can't come down like that, like trying to make a triangle, is it?
It cannot come down because there's no value giving us.
There's someone who wants to ask as well.
Chirofia.
Okay, sir.
Sir. So it's always a mandate to bend it towards the positive side of this is a function here. F of x is equal to 9 minus 0.
9 minus 0. What do you mean to bend it?
Like here, because the point was for 9, and then I thought maybe to go straight in the upward direction.
This is a quadratic. So a quadratic is a curve. So you always connect your points using a curve. It's not a straight line. So the fact that we had 1, 2, 3 points, it's enough for us to sketch because we just go around those points.
So, sir, how do you tell that this graph is a quadratic something?
If it's squared, x is squared, then it's a quadratic. If x is not squared, then it's a line.
Sir, I have a question on the quadratic. There's this other part on the condition. There's this other part that says x should be less than 3. But if you solve this quadratic, it will give you -3 and 3. So how do you deal with because this 3 is restricted. So how do you deal with it?
So we had opened there to show the restriction. Had it not been for the third piece of the function, which closed at 3 there, that point would have remained open.
So meaning that it wouldn't have come down, or you mean it would have just been open, like
it would have gone down. It would have gone down, but it would have been open at the end point.
Okay.
Yes.
So I don't know if you had already explained why it doesn't proceed, why these straight lines don't proceed. I didn't get why don't they proceed?
To which direction? Going down.
To the down, yes.
Because the number that you are using,
So, what if you have this question whereby you have 9 minus x cubed? How can it be plotted?
9 minus x3. That one becomes a different question. It becomes a polynomial of degree 3. So it will be a different sketch, which we will sketch when you look at polynomials. Okay. Why don't they proceed going down? Because the domains restrict them.
Okay, sir, thank you. But the domain for the first one says it's open, so
it was open in red, except that the second function came to close.
Oh, okay, thank you.
Do you still have questions?
Sir.
Hello. So it's like my network is cutting for So if your network is a bit weak, you can as well type it as a message. I will read the message in the chat here. Blessings.
Sir.
Hello.
Sir. But how did you connect the intercept and the turning point? How did you know that the intercept is the turning point?
How do I intercept the turning point? Because we're looking at the values of x that we're dealing with and the nature of the function. When x is squared, it always gives us positive values. So if it is whether negative or positive, for as long as the number is not 0, the quantity there would increase in the positive direction. If it was -2, you would get -2 squared, that is 9 minus 4, giving us 5. 5 is less than 9. The same thing would happen even if it was positive. This means that you always, and that's how we even know if they ask us to check for the range. If the function is squared, you always look at the least value of x that can give us the maximum value of 9 minus x squared. And it's always 0. Or since we did computing the square, we are able to see that if the function is in this form, a x minus b over 2a plus whatever is there, the intercept is b over 2a, comma, that thing which is there. That is the turning point. So if you try the turning point method here, you would see that line of symmetry is actually 0, 9. Mean now I'm not talking about the turning point. So line of symmetry is 0, the maximum value is 9, since a is negative. Okay, so I'm still taking questions. We have 2 minutes before the 40 cuts, so we can't start a new question. I don't know if somebody is talking in the background. We can't hear. It's network.
Oh, sir, I was asking about the openings. When is it open and when is it closed?
So here is the guide. If it's less or equal to, greater or equal to, you close. If it's less or greater, you don't close, you open. That's how you get to know. Okay, so let's log out and get back. That we leave, you join. So we continue up to 15 hours. No, don't get depressed. We are going to do nice ones now.